Okay, so um, what I'm going to show you next is how to describe the change of this pre-image right here down to its image. Okay. And all of this is being discussed in these next few questions. So it's not that I'm not skipping these. I'm doing them. I'm just doing them up here where the drawing is. Um, so it says here compare transformation one. How do the transformations compare? They both moved, but this one changed size, this one didn't. Rigid motion um is it didn't change size. Transformation number two um was not rigid motion. Here we are going from the pre-image, the coordinates to the coordinates of the new one. Okay, so this one is the point 110. Okay, that's the point 110. And then we moved that point till we get to this one over here. And I know I'm going I'll show you something that I'm sure that it comes up in the next lesson or two. But if this was called point A, then the new point, which is this one right here, would be called A prime. Okay, so this point right here is A prime. So if A is at 110 and A prime is at 1,4, oh, my 4 looked weird. Then how would you describe the difference in these two ordered pairs? Well, hopefully you'd see that the X value didn't change at all, and the Y value changed by, it got what? We went down 6. Isn't that what happened? 1, 2, 3, 4, 5, 6. So the Y value is 6 less. Okay, so here's the notation that they use. Ignore that little dot. So XY, this is your pre-image. Okay, this is your pre-image. And then we draw this little arrow over. And again, that's not supposed to be anything. And this becomes the image point. This is the image. Okay, so what did we say happened? We said the X value stayed the same. So whatever the pre-image X value is on any of your endpoints that you want to do, the X value is going to stay the same. So whatever this X value is, that X value is the same. But the Y value, this Y value right here, remember we're talking about the 10. How do we make a 10 become a 4? Well, you take whatever the Y value is and you take away 6 from it. So that means that if we take any point that's on this pre-image, and it doesn't have to just be these vertices right here, it could be any point. You take a point in the middle, you could take the middle of one of the sides, you could take a point in the middle here. It will transform it to its corresponding point into the image. It'll take the pre-image point and transform it to the corresponding image, the corresponding point in the image. So if B right here is the point, what is it? 610. B is 610. So B prime right here, B prime is going to be, so what are we going to do to the X value? The X value is going to stay the same. And what are we going to do to the Y value? We're going to take away 6 from it. So B prime is going to become the 0.64. And you can see, there it is right there. It's the 0.64. That's B prime. And the same would be true for these 2 points. This point right here is the 0.12. So you take the 0.12. The X value stays the same. It's 1. And then you take 6 away from 2. 2 minus 6 is -4. And you see that that's where C prime ended up at 1, -4. And then D prime would end up at this point right here is at 6, 2. So this point is going to be at 6, -4. Ooh, those fours. So the x for this transformation, the x value stayed the same and the y value, we would say translated down 6, because we subtracted 6. So what did we do to the pre-image? We shifted it down 6. We translated it down 6. And you can go, both directions. You can go either left or right, or you can go up and down. This is what we just did. I just did those up here on this picture. So if you want to go back and fill those in, you can. Here's, pay attention to this. The arrow notation shows that it stands for the words kind of goes to. The 0.110 goes to the 0.14 for this transformation. Here's another one right here. They're giving you, what is this called? This is called the pre-image. And the pre-image, we are transforming this, translating the transformation. The specific transformation is a translation. And we recognize it as a translation because of the plus and minus. When it's multiplication down here, multiplication is always non-rigid. So I know that this multiplying both of these numbers by 2, this is going to change its size. We're going to change its size. And because we're changing its size, we know it's non-rigid. But this one, all we're going to do is take each one of these ordered pairs for the vertices, or any other point that you want. You don't have to take. You could take this point right here and transform it, and then you would know that it was the point that was, located inside that square. But you take these, and then this is how you change the x values. Now, I can also describe this translation. This is a translation, and I know it's a translation because it's a plus sign. And I know since we're adding 3 to the x value, we're going to be going a translation right. We're going to be moving it to the right because we're increasing the x value by 3. So all we're going to do is take this point right here, and we're going to move it 1, 2, 3. So this point is going to slide this way, and then this point is going to move 1, 2, 3. It's going to end up right here. Okay. This point is going to slide over to this one, and then this point right here is going to slide over to this one. So that's where we're going to end up. You can also do it by the ordered pairs. So I'm assuming that this scale down here is 1. So this point right here is at 1, 2. Okay, so this point right here is at 2, 2. So what does this tell me to do? It tells me to say 2 plus 3. So 2 plus 3 is 5, and then the y stays the same. So 1, 2, 3, 4, 5, up 2. And again, it makes it so much easier if we name these. If this is A, then this is A prime. Okay, B is right here at 2. And then 2, 3, 4, 5. It's already at 2, 5. This point right here is at 2, 5. So we plug the 2 in. 2 plus 3 is 5. And then the y value stays the same. So my next point is going to be at 5. 1, 2, 3, 4, 5. And if we called this B, then this would be B prime. And then we would continue. This is going to be C prime. This is going to be D prime. And then this is the new location. And of course, you could put your ordered pairs. So on the final, by the time you're through with translations, you should be able to take any piece of information that we give you. You should be able to take a picture, a pre-image and an image, and you should be able to write the transformation using this notation right here. Or you should be able to do like they ask you right here, given the pre-image and the transformation rule, come up with the image and the coordinates for the image and so forth. You should be able to go, in any direction. You should be able to start with I should be able to give you the image, and then you undo the transformation to come up with the pre-image. Okay, so you may have to work backwards. This one you do exactly what it looks like you're supposed to do. You take each one of these ordered pairs. This is the point 1, 2. This is the point 3, 2. This is the point 3, 3, 4, 5. And this is the point 1, 5. You take the X values and double them, and you take the Y values and double them. So your new points will be 1 times 2 is 2, and 2 times 5 is 10. So you end up with the point 210, 610, 2, 4, and 6, 4. My 4s do not look like 4s. So 1, 2, 1, 2, 3, 4. 1, 2, 3, 4, 5, 6, 4. And then 2, 4, 5, 6, 7, 8, 9, 10. And then this one. And so now we have a rectangle that is bigger than the original was. This side was 2. Now this side right here is 4 units long. This side right here was 3, and now it's 1, 2, 3, 4, 5, 6. It's 6 units long. Why? Because we changed its size. It was doubled, so it was non-rigid motion. Okay, I'm going to stop this video here before I move on.